Okay, class, you're welcome to another exciting video lesson on my YouTube channel, Master Science Guide. Now, in today's video lesson, we're going to be talking about a very important organic reaction in the world of organic chemistry, and it is called the haloform reaction. It is called the haloform reaction. Please, this video lesson is for A-level students, alright, students who are offering chemistry in their first year in college and universities. All right, so now the haloform reaction, what is this reaction all about? Now, first of all, the haloform reaction, it has to do with a reaction. It is a reaction, all right, between halogen, we can use chlorine, bromine, or iodine, all right, between halogen in the presence of base NaOH, reaction between halogen in the presence of base NaOH with carbonyl compound having a methyl carbonyl group. All right, now this haloform reaction, let me explain. Basically, the haloform reaction is a reaction between halogen with carbonyl compound. The reaction between halogen with carbonyl compound, but then this reaction occurs in the presence of a base known as sodium hydroxide, NaOH. All right, now, but there is a little twist to this reaction. And what's the twist? You must make sure that the carbonyl compounds, pay attention, the carbonyl compound that you can use, all right, to undergo haloform reaction with the halogens, the carbonyl compound must have a methyl carbonyl group. Now, first and foremost, what are carbonyl compounds? Now, listen up. Carbonyl compounds, when we are talking about carbonyl compounds, all right, carbonyl compounds are mainly the aldehydes and the ketones. Carbonyl compounds are mainly what? The aldehydes and the ketones. Okay, but excuse me, in this reaction, ketones are mainly used. In this reaction, ketones are mainly used. All right. Now, the reaction is it's a very specific reaction because there is a certain condition that must be met. Now, when we say a methyl carbonyl group, now what are carbonyl group? Carbonyl group, I dropped a video lesson about alkyl and acyl group. All right, please go and watch that video. Now, carbonyl groups are, or a carbonyl group refers to carbon doubly bonded to oxygen. This is a carbonyl group, carbon doubly bonded to oxygen. So a methyl carbonyl, so we are having just what now, a methyl group. So we can have something like this. So this is what we call methyl carbonyl. So be it aldehydes you want to make use of or the ketone, you must have the aldehyde or the ketone must contain a methyl carbonyl group. That is the condition. Now, having seen this, now let's take a practical example. Look at this, for example. Now, if you take ketones, for example, now let's take this ketone. Let's take pentathione, that is CH2, CO, CH2, CH3. 1, 2, 3, 4, 5. So there are 5 carbon atoms. Now this is pentatirione. Pentatirione. So this kind cannot undergo haloform reaction. This kind cannot undergo haloform reaction. Why? Because it does not have any methyl carbonyl. So this is where you have the carbonyl group. On this side, this is ethyl. This is not methyl. On this side, this is ethyl. This is not methyl. So from any direction, it's not going to give us a methyl carbonyl group. Alright, it does not have any methyl carbonyl group, so it cannot undergo haloform reaction. Now let's look at practical example on how this haloform reaction simply explains. Let's look at the practical example. Say we have penta 2-O, for example, that is CH3 CO CH2 CH2 CH3. Now, can this guy undergo haloform reaction? Yes. Why? Because if you look at this side, this is a methyl group, this is carbonyl, so it has methyl carbonyl, so it can undergo haloform reaction. Are you getting it? It can undergo what? Haloform reaction. So this guy will react with an halogen. Now in haloform reaction, all right, you can use chlorine, you can use bromine, you can use iodine, but then the halogen that is commonly used is iodine. So I'm going to have iodine, all right. Now it will react in the presence of sodium hydroxide, and what are we going to get? We are going to get iodoform, CH then I3, all right, plus we'll now get CH3 CH2 CH2 COONA, a salt. All right, we're going to get iodoform, which is the IUPAC name is known as triiodomethane. All right, triiodomethane, which you can just simply say iodoform. That's just the common name for it. All right, so we can also use chlorine. All right, we can even use bromine. All right, so let's try to work with bromine. So, or chlorine, let's use chlorine. So think of any compound that can, any of the carbonyl compound between aldehydes and ketones that will give you, we're going to have a methyl carbonyl. So we can use ethanol. Say CH3 CHO, this is ethanol. So we can rewrite this as C double bond OH. Now it has a methyl carbonyl. So this can also react with chlorine, presence of NaOH. So now give us our CHCl3. Alright, then plus our CHCOONA. Right, HCOONA. That's what we are going to get. So this is chloroform, or you can say trichloromethane. Now ethanol can be gotten from the oxidation of ethanol. Ethanol can be gotten from the oxidation of ethanol. So that also means, now listen, ethanol can also undergo haloform reaction, simply because ethanol can be oxidized to a carbonyl compound which has a methyl carbonyl group. It does not just have to be a methyl ketone. Ketone is a carbonyl compound or a carbonyl group. So it's part of the carbonyl family. Aldehydes and ketones, they are the main carbonyl families. All right. So ethanol can be oxidized to what now? To ethanol, which is a carbonyl compound that has a methyl carbonyl group. All right. So ethanol, being an alcohol, can undergo haloform reaction for this reason that I just explained. It can be oxidized to ethanol, which has a methyl carbonyl group. So this is the summary of haloform. Now please take note that triiodomethane, aka iodoform, is antiseptic. It is antiseptic, right? It has an antiseptic smell. You know, when you go into hospitals, there's one smell you usually perceive. You know, that's iodoform. All right, that is iodoform, and it's a yellow solid. It's a yellow solid. It is iodoform. It is also what? Antiseptic. It is very important. So thank you very much for watching this video lesson. Please, if you like this video, do it to like, do it to subscribe, and share to your friends. This is a summary or everything you need to know concerning the haloform reaction. Thank you very much for watching this video lesson, and I'll see you in the next video.